Hello students, welcome back. Myself Uday Soni, Mathematics faculty for JEE Main and Advanced. Let us start lecture 3rd of inverse trigonometric functions. Okay. See, today we'll discuss type 3. In the previous video I have discussed type 2. Okay. So in type 3, look here. On the left side you will be given a inverse trigonometric function, okay, inverse trigonometric function, and on the right side you will get inverse trigonometric function but the other one, okay. In case suppose here it is given as sine inverse x, then the right hand side will be in other t ratios like cosec inverse x or tan inverse x, something like that, okay. And the input will not be in form of x, it will be a new function, okay, g of x, okay. Now we will see one by one, okay. In type 2 I left out two questions, okay, we will see in this lecture. The first one is tan inverse x, okay, tan inverse x, hold on, tan inverse 1 by x is equal to, you will get two solutions here, okay, for x positive and for x negative. So your answer is cot inverse x if x is 0 to infinity, means if x belongs from 0 to infinity, your answer will be cot inverse x. But if x belongs to minus infinity to 0, means when x is negative, your answer is cot inverse x minus pi, okay. Now the students make mistake here, okay, they don't know when to put minus pi or plus pi, okay. So I will make it very clear, okay. From this you can understand very easily what I am teaching, okay. Hold on, look here. Before starting, let me show you something. See this three questions in type 1, 1, 2, 3, okay. These three questions in type 1 and these three in type 1, okay, for sine, tan and cosec. When you give negative input, your output comes out to be negative of that function, isn't it? Negative of sine inverse x, negative of tan inverse x, negative of cosec inverse x. But in case of cos inverse minus x, your output comes out to be pi minus that function, isn't it? Pi minus that function, pi minus that function. So type 1 you have to remember, okay, how it came. I taught you in that lecture itself, okay, lecture 2. So look here, I will take the functions which is given on left hand side as alpha, okay. This function is alpha, and the functions which we are getting on right hand side, the other trigonometric function, I will take this as beta, okay. So when for positive input, okay, this is for x greater than 0, okay. When x is greater than 0, means from 0 to infinity, your input is positive, isn't it? So how will the function this look like? Nothing, same, right? This function will be remaining same. So I am taking this function as alpha, and in case of this function, when you give positive input, how will the function look like? Nothing like what? It will look like same, right? So it is beta. But for x less than 0 means when x is from minus infinity to 0, here your input is here. See here your input is negative, isn't it? So for that, what is the answer? Look here. When you give negative in the input, your answer comes out to be negative of that function. So come here, I'm giving here negative, then negative of that function will be minus alpha. I have taken this function as alpha and this function as beta. Okay, so it will come minus alpha. And when you give negative to quote, how does it look like? Negative to quote, look at the second one here, this one, pi minus that function, isn't it? So here we will get pi minus quote is beta. Okay, so we need to find alpha, isn't it? So alpha will be equals to multiply negative both sides, beta minus pi. This is what you got here. See, alpha means tan inverse 1 by x. Okay, and on the right hand side you got what? For x less than 0, minus infinity to 0, you got beta minus pi. So beta is cot inverse x minus pi. Are you getting? Okay, let me do one more, you will understand it very clearly. Okay, now let me do it for cot inverse 1 by x. Okay, see here, for cot inverse 1 by x. Okay, I am converting it into 10, so it will be tan inverse x when x belongs to 0 to infinity. Okay, look here, now this function will be alpha and this will be your beta. Okay, so when you put positive input here, means first case is for x greater than 0. Okay, means x when x belongs to 0 to infinity, how will this function look like? Nothing but same, right? Alpha will remain alpha and this function beta will remain beta. So no problem in case of positive. Okay, no problem in case of positive. But when you take negative input for x less than 0, okay, means x belongs to minus infinity to 0, what will be your function here? Let us try. Okay, when I am putting negative input in this function, okay, negative input, it will give you pi minus that function itself, isn't it? Is equal to, when you give negative input here, how it looks like beta. Okay, negative of that function, isn't it? You please see these 6 questions. Okay, in my previous lecture I have taught you. Please see these 6 questions, you will understand it. Okay, pi minus alpha is equals to minus beta. You need to find what? Alpha, right? So your alpha will be equals to, alpha will go right side and beta will come this side, so it will be pi plus beta. So your alpha is pi plus beta. Okay, this one was your beta, isn't it? So here you may write pi plus what, beta here is tan inverse x. I hope this is very clear. Okay, you practice. Okay, today we'll be doing more questions on this type. Okay, it's not a question, but we can say it as a formula. Okay, people, they get very tough in memorizing these formulas, when we have to add pi, when we have to subtract pi, what we have to do, what don't. So now let me give you another one. It was very easy, right? So let me take you other page, a blank page. Here sine inverse x. Now I will try to convert this sine inverse x in cos inverse x. Okay, how do you convert it? First we will draw a triangle theta. This is x, this is 1. So by Pythagoras theorem, what do you get? Under root 1 minus x square. Your base comes out to be under root 1 minus x square. Okay, let me write it clearly. Okay, let theta equals to sine inverse x. I am writing each step. Okay, later on I won't be writing these things. Okay, sine theta comes out to be x. So when sine theta is x, means x by 1, isn't it? So it is perpendicular by hypotenuse. Now from this triangle, try to find out cos. Okay, your cos theta will be equal to under root 1 minus x square, under root 1 minus x square divided by 1. Okay, divided by 1 is not necessary, right? So just remove it. Got it? 1 minus x square under root. Okay, so from here you can say that your theta is what? Cos inverse under root 1 minus x square. Now you can say that from equation 1 and 2, here this is 1, this is 2. From 1 and 2 we can say that sine inverse x is equal to 1 minus cos inverse under root 1 minus x square. Okay, every time when you have to convert one trigonometric function to other, you will just draw this triangle. Okay, and you can find the other one. In case of sine inverse x, if you want to convert it into cos inverse x, how it looks like? It looks like this. Okay, so let me convert it. For positive, no problem, right? When you give positive input here, you don't have any problem. So your answer is cos inverse under root 1 minus x square. Okay, this is for x belongs to, tell me, for x belongs to 0 to 1. Okay, means x is from what? Our domain in case of sine inverse x, it is from -1 to 1, right? So when x is positive, that is from 0 to 1, you can directly write this, because in this case alpha is equals to beta. We don't have any problem. But when you take negative input here, this is for, again let me take hold on, let me take orange ink and let me write it down. For x greater than, not x greater than 0 exactly, it is x belongs to for x belongs to 0 to 1. Okay, your alpha is equals to beta, and for x belongs to -1 to 0. Okay, 0 will be open, okay, here, because we have already taken 0 in the first case. So when you give negative input, how it looks like? It looks like minus alpha, isn't it? This function is your alpha, so it will look minus alpha. Okay, in type 1 we have seen this, right? Now you try to give negative input here. Okay, whatever input you give here, what cos will see its input? For cos inverse x, this whole thing will be input. Okay, and this is always positive, we know now, because it is under what? Under square root, so your output will always come out to be positive. Look here, here is x square, you put minus x square, it doesn't change, right? So these things remain same, so here you'll be left with beta only. Okay, the right side won't change, because for cos inverse x the input is always positive. Okay, so what will be alpha here? Alpha will be equals to minus beta. Okay, multiply minus both sides. What is the answer? Minus cos inverse under root 1 minus x square when x belongs to -1, 0. Okay, I hope it's clear. Okay, the alpha beta concept, isn't it? We will take the left function as alpha and the right functions as beta, and we will use type 1 to verify it. Okay, let me make this thing more clearer. Okay, how you can write these things. Okay, coming to the next page, see in the bracket what I wrote? Cosec inverse, isn't it? So I'm still in the previous one. Okay, you can write that also, and you can write in this way also, that cos inverse under root 1 minus x square is equals to what? Sine inverse x, or minus of sine inverse x for x belongs to 0 to 1. Okay, and here for x belongs to -1 to 0. Okay, you can write the other way. Okay, just I'm doing nothing but just transferring the left side to right and right one to the left side. Okay, and how do you write this in very short form? You can write like this also. Okay, sine inverse mod of x. Okay, x belongs to -1 to 1. It will automatically take negative and positive. Okay, I have given here as mod sign. You already know what mod do, okay, isn't it? It just gives the positive value. Okay, so I think this is clear. Okay, when you put -1 to 0, here you will see a negative sign, it will come out as minus x, so minus will come outside, isn't it? And when you give 0 to 1, you will get a positive one. So let me give you another question. Now I am converting cos inverse x to sine inverse x. Okay, let me convert in the similar fashion. Okay, this is the other one. Okay, other question. Hold on, the other one is cos inverse x is equal to, directly from the triangle. Okay, cos x is x by 1 So this will be 1 minus x square. Now in case of sine, how will it look like? Perpendicular by hypotenuse, your sine will look like sine inverse what? Under root 1 minus x square. Okay, under root 1 minus x square. When this happens, when x belongs to 0 to 1. And now let us try for the negative one. When you give here negative, input negative, okay, means x belongs to -1 to 0. When your x is negative, this function, it will give you pi minus alpha, isn't it? And this function, put negative in place of x, put minus x. What happened? Nothing changes, right? So this thing will remain same. When you put negative here, x square, okay, minus x square, it will be same, right? So nothing changes here, it will be beta only. So how is your alpha? What is your alpha? Alpha is pi minus beta. Okay, so it will be pi minus beta is what? Now sine inverse under root 1 minus x square. Remember, the left one is alpha and the right side is beta. Okay, rabbit not needed, isn't it? So you got it right. Now you can write this as, how you can write? You can write this as, here I am writing in the next page. Okay, this implies the other way. Okay, taking right to left and left to right. Sine inverse under root 1 minus x square comes out to be what? Cos inverse x. X belongs to 0 to 1. Okay, when your x belongs to from 0 to 1, it is cos inverse x, and the other one will be pi minus cos inverse x. X belongs to -1 to 0. Okay, doing nothing, but I'm just, hold on, nothing but I'm just shifting this to right. Okay, and I'm bringing this to left. Okay, here when you shift sine inverse x to the right, it will become positive, and on the right hand side pi will be remaining, so bring cos inverse x this side, so it will be pi minus cos inverse x. Okay, I think this is clear, no need to explain too much now. Now let us see one question. Now convert is other question. Okay, tan inverse x to sine inverse x. How do you convert? We first draw the triangle. Tan inverse x means this is x by, if nothing is there, by 1 is there, right? So tan inverse x is perpendicular by base. Okay, perpendicular by base. So your hypotenuse will be 1 plus x square, isn't it? So when you convert it to sine is perpendicular by hypotenuse. Okay, sine is perpendicular by hypotenuse, 1 plus x square. Okay, now let us try to solve it. You put positive, okay, for x belongs to x greater than 0. Okay, when x is greater than 0, here left hand side will be alpha and your right hand side will be beta. Nothing changes, right, when it is positive. But when x is negative, okay, when x is negative, this side it comes out to be minus alpha, okay, this will be minus alpha, and right hand side when you put negative here, this x square, it will be same, right, under root it will be 1 plus x square, because when you put minus x in place of x here, in place of x if you put minus x, nothing will change because of this square, right? But in the numerator you have got a x, okay, it will make the whole input negative, isn't it? So when you give negative input to sine, what is your answer? Minus of beta, isn't it? It comes out to be minus sine inverse x from type 1, okay. Since the input this is negative, so your answer is equal to sine inverse of minus x is equals to minus sine inverse x. That's why I've written here minus beta. The other function is beta, isn't it? This is beta, this is alpha, okay. This function is beta and this function is alpha. Just rub the unnecessary things, okay. So this negative gets cancelled out, isn't it? The negative both sides will get cancelled out. Alpha will be equals to beta, okay. This is for x greater than 0 and this is for x less than 0, okay. For x greater than 0 you are getting this, and for x less than 0 also you are getting alpha comma alpha equals to beta. So for both you are getting the same answer, isn't it? So you can directly write here. I'm writing, okay. I hope you understood, right? So write it down. Here also you can write sine inverse of x divided by under root 1 plus x square, or you can directly write sine inverse x divided by 1 plus under root of 1 plus x square, okay, comma, for all x belongs to real number, okay. I hope you got it, isn't it? For x belongs to x belongs to all real number, okay. Tan inverse x is equal to sine inverse x divided by under root 1 plus x square for all x belongs to real number, okay. You just give a try, okay. I'm giving some questions, and if you're unable to solve it, please ask me, okay. I will give you some questions, okay. Convert this one. Your first one is tan inverse x is equal to, you replace this by cos, okay. You convert this into cos. The other one, tan inverse x, you convert this into what? You convert this into cot, okay. This into cos, this into cot, and the third one is cot inverse of x is equals to, convert this into tan. Okay, and just compare your answer. Okay, I will solve this in my next lecture. Okay, so please try. Okay, I think this is very easy, so no need to get panic. Okay, everything you understand by time. Okay, when time comes, everything